In 6.2, we will be factoring trinomials of the form ax squared plus bx plus c. Before I go over exactly how to do this, I want to tell you what factoring really means. I want to define factoring in just some generic terms. When we factor, we basically mean to write as a product. But when we say write as a product, what does that even mean? That's just a bunch of words and it doesn't tell me much. Let me show you what it means. You can see on this screen that we have on the left side over here, we have two binomials. And on the right side, we have a trinomial. So as you go from the left to the right, what happens is that you multiply. Right? I mean, we know how to do this. We can multiply these two binomials, x plus 2 times x plus 3, and we get the trinomial x squared plus 5x plus 6. We should have been able to do that and known how to do that for a while now. But what's interesting, if you look from the right and go to the left, you're no longer multiplying. If you had a trinomial and wanted to turn it into two binomials that were multiplied together, that would be factoring. And that is what we mean by writing as a product. We're taking this trinomial and wanting to write it as a product. Our first example is x squared plus 7x plus 6. Now, anytime you're factoring, your first step will always be to look for the greatest common factor, and thankfully we learned how to do that in 6.1. But as you can see, the trinomial x squared plus 7x and plus 6 does not have a GCF. We then multiply our a term and our c term, which is 1 and 6, together to get 6. And see, what we're looking for is two factors that multiply to give us 6 and add to get that middle number, which is your b term. So we want to find all the factors of 6. So I go through all my numbers. 1 times 6, 2 times 3, and 3 times 2. I always stop when I start repeating. And I did that right here with the 2 and the 3 and the 3 and the 2. So these are my numbers that multiply to give me 6, but they also have to satisfy this second part. They have to add to give us 7. And you can see 3 and 2 add to give us 5, and 2 and 3 give us 5, but 6 and 1 add to give us 7. And once you find the numbers that you want, 1 and 6, you put them off to the side. And you want to put the a term, which is 1, and an x in the denominator. The 1 again comes from the a term. The x comes from the fact that x times x gives us x squared. Once you have put this in the denominator, you want to then simplify these fractions. These fractions don't really simplify. You could just write them as 1 over x and 6 over x. Once they are in their simplest form, you would then put the bottom up front. So for this first fraction, 1 over x, that would be x plus 1. Again, it's a plus 1 because it's a positive 1. And x plus 6. And that is our answer. Now, if I wanted to, that x plus 1 and x plus 6, I could check to make sure that that's the correct answer. Because you see, I took a trinomial and I factored it to write it as a product. But what this should give me is two binomials that multiply to give me the original trinomial. So let's see, I can multiply this out, and I'll get x squared plus 1x plus 6x plus 6. And that gives me x squared plus 7x plus 6, which is my original trinomial. So therefore, my answer of x plus 1 and x plus 6 was correct. In our next example, x squared minus 8x plus 15, we have to remember that our first step in factoring is to look for greatest common factor. But there is no greatest common factor. So then I move ahead and I multiply my a term and my c term to get 15, and I realize that I'm multiplying to get 15, and I have to add to get negative 8. So let's find all the factors of 15. We have 1 in 15, 2 doesn't go into it, 3 goes into it 5 times, 4 doesn't, 5 goes into it 3 times, and I have started repeating so I can stop. So now I want to think about the fact that I have to add these two numbers to get a negative 8. Well, when I'm multiplying to get the positive 15, if I'm multiplying to get a positive number, they have to be the same sign. See, you multiply a positive times a positive, you get a positive, and you can multiply a negative times a negative to get a positive. The numbers have to be the same sign in order to give you a positive number. If I'm going to add these two same signed numbers together to get a negative, that would mean they would both have to be negative. So let's test these out and see if anything works. Negative 1 times negative 15 is 15, but they add to give me negative 16. Negative 3 times negative 5 is positive 15, and they add to give me negative 8. So before I even went any further, I had my two factors, my two numbers right there. So I want to take the negative 3 and the negative 5, put them off to the side, and I'm going to put my a term, which is 1, and an x, because x times x gives me x squared in the denominator, and I want to simplify that. Well, it doesn't really simplify. I could just get negative 3 over x and negative 5 over x, but there's no sense in rewriting that. Once the two fractions are in their simplest form, you can just put that bottom, which is 1x, but I'm just going to write an x out front. So x minus 3 and x minus 5. Do remember that you can check this by multiplying these two binomials together. When you multiply them together, they should give you your original trinomial. But that's just an extra step. This is our final answer. X minus 3 times x minus 5. In example number 3, again, our first step is always the same. We have to look for a greatest common factor. As you can see, there is not one. So then we have to multiply our a term and our c term together to get negative 18. And I always like to write this little statement. You can see in our notes here that it doesn't have it there for us this time, but we can write it ourselves. So we're multiplying to get negative 18. But we need to add to get negative 3. So let's try this out. I want to list all my factors of 18 first. So I have 1 times 18 and 2 times 9, 3 times 6, 4 doesn't go into it, 5 doesn't, and I have 6 times 3. Now I want to think about the fact that I have to multiply to get a negative 18. You can see that my signs here, like positive 6 times positive 3 is not negative 18, it's positive 18. So we know that when we multiply to get a negative number, one of the numbers has to be negative. They're going to be different signs. But we have to add these two different signed numbers to get a negative 3. So if we're adding two numbers of a different sign to get a negative number, that means that our larger number is negative. So I'm going to go through here. I'm going to make these larger numbers negative. and see what they add to give me. Okay, so 1 and negative 18 adds to give me negative 17. 2 and negative 9 adds to give me negative 7. 3 and negative 6 adds to give me negative 3, and I think that's what I'll use. So I take the 3 and I take the negative 6, I put it off to the side, and I'm putting a 1x. Remember, 1 comes from this a term, and x comes from the fact that x times x gives me x squared. I'm not going to put the 1 in front of it this time because I feel like we're a little bit more advanced at this point. So once you have done that, our fractions now are in their simplest form. They can't be reduced. So when your fractions are in their simplest form, you just want to put that bottom up front. So x plus 3 times x minus 6. That's our factors of the trinomial x squared minus 3x minus 18. Again, our first step is always to look for the greatest common factor. And you know what? This time I really want there to be one. I see that there's two different variables in this trinomial and I'm looking for a GCF, but there's not one. That x happens in the first part, in the second part, but there's not an x right here with the 4y squared. The same thing with the y. I want it to happen in all three parts of this trinomial, but I don't have a y up front with the x squared. There's no GCF, as much as we want there to be one. So now I just do my same thing. My rules for factoring this trinomial are the same. It looks different, but I start out the same way. I looked for my GCF, there's not one, so now I multiply my A term and my C term together to get negative 4, and I'm going to write that little statement that we like to write. We are multiplying to get negative 4, but we're adding to get negative 3. So let's find the factors of negative 4. We have 1 and 4 and 2 and 2. I've started repeating. I can stop. So I'm multiplying to get a negative 4. That tells me that my signs of the number have to be different. Since I'm adding these two different signs together to get a negative number, that tells me that my larger number has to be negative. And, well, right here, when I go to make one of these negative 2 and 2, that's the same number. If I make one of them negative, that adds to give me 0, so I needed to add to give me negative 3. I know 2 and negative 2 won't work. Let's see about 1 and negative 4. 1 plus negative 4 is negative 3. So that's what I want to work with. I put a 1 off to the side, and I put a negative 4 right there with it. I do the same thing I've been doing. I've been putting an A term, so 1, and x, because x times x gives me x squared. But let me tell you why we do that x. Okay, see, the x is descending in power in this trinomial. We start off with an x squared, then we have an x to the first power, and then whenever you get over here to 4y squared, there's no x at all. X is descending in power. It's getting smaller. Do you see that we have another variable doing the exact opposite thing? Y is ascending in power. It goes from the second power to the first power. And right here up front, there's no y at all. So let me say that again. X was descending, so it went down in the bottom. Y is ascending, so it goes up top. Okay, now we're at the point where we want to look and see if these fractions are simplified. And you could write them as y over x and negative 4y over x. That is a little bit simpler, more correct form. Once they're in their simplest form, you just want to put that bottom up front. Bottoms up. X plus y and x minus 4y. That's our answer. So we finally have a greatest common factor. Remember, that's always been our first step. Whenever we're factoring anything, we always look for a GCF. And in this trinomial, we had a GCF of 3. So, factor out your GCF, and then your second step is the same. We multiply our A term and our c term together to get negative 10. So I can write my statement. I'm multiplying to get negative 10, and I'm adding to get that b term of 3. So I list all my factors of 10. 1 times 10, 2 times 5. 3 doesn't go into it. 4 doesn't, but 5 does twice. And so the fact that I'm multiplying to get a negative number tells me that my signs are different. And I'm adding these two different signs together to get a positive number, so that means my larger number is positive and the smaller number is negative. So negative 1 and 10 give me positive 9. Positive 5 and negative 2 give me positive 3. So I think that will work. We take our negative 2 and our 5, we put it off to the side. Right here we want to be careful. X times x does multiply to give me x squared. And our a term is still 1. A lot of people think our a term is 3, but no, that's our GCF. See, our original a term in the original trinomial was 3. That 3 right there. But our new trinomial, the a term is 1. And that's the trinomial we're factoring. So I put, once I have my two fractions and they're simplified, I put that bottom up front. So I have an x minus 2 and x plus 5. And the thing I don't want to forget is my GCF out front. So that would be my final answer. And this next trinomial, we want to have that same first step of looking for the greatest common factor. And in this trinomial, it looks like we have a greatest common factor in the numbers of 5, because we have a 5, a 25, and 120. And then our variables are x and y, and that happens in all three parts of this trinomial. Our lowest power of x is to the first power, and our lowest power of y is to the first power. So our greatest common factor is 5xy. So if I factor out a 5xy, I'm left with x squared minus 5x minus 24. Once that GCF is factored out, I want to multiply my a term and my c term together to get negative 24. And if we want, we can still write that statement of multiply to get negative 24, and we're adding to get that middle term of negative 5. So 24, that would be 1 times 24, and 2 times 12, and 3 times 8, and 4 times 6. 5 doesn't go into it, and 6 times 4. I've started repeating, so I can stop. And now I want to think about the fact that this is a negative 24 that I'm multiplying to get, so my signs are going to be different. Since my signs are different and I'm adding to get a negative number, that means my larger number is negative, the smaller number is positive. So I add negative 6 and 4 together to get negative 2, the same thing right here, and negative 8 and 3 give me negative 5. I think that's going to work, so I take the 3 and the negative 8, and I put 1x in the denominator, and it doesn't simplify, so I go ahead and put that bottom up front. And never forget your greatest common factor.